Okay, this will be a video on section 9.6. So this is to add to things we've already talked about. So in class, we did already talk a little bit about how to graph these on number lines. So I'm going to go through these examples a little bit quick just to go through it and explain it. So to graph on a number line, and when you draw your number line, it is absolutely not necessary for you to draw like the whole entire number line. Just draw a number line with arrows on both ends and put a 0. And then put the numbers that are relevant. And in this case, it's only -5. So be sure the negative's to the left. Of course, smaller numbers are to the left, bigger to the right. And then when we graph it, what we have to pay attention to is this right here. So this is red, x is greater than or equal to -5. So we learned that when you have greater than or equal to, you're going to use a square brace. So that's what you're going to put on -5. And then greater than, numbers that are bigger than -5 would be numbers to the right. And so we're just going to shade to the right. So you're just going to make it big. And then I always shade the arrow also to make it really clear. So that's how you graph it on a number line. The other thing we're going to do every time is we're going to write interval notation. So instead of just the number line, every time go ahead and do interval notation. Well, once we learn how to do it on the number line, interval notation is easy. So your interval is going to use the same symbol that you used up there. So we used a square bracket because -5 is included. So we use a square bracket here. It's always smallest to largest. So -5 is the smallest, and then comma, and it goes all the way to infinity, because that's why the arrow is shaded. This never ends. It's anything that's bigger than -5. And we always use parentheses on that. So I think in class we talked about that infinity always has parentheses, and included is brackets, and parentheses is not included. Since infinity isn't actually a number, that's the reason it needs to be parentheses. All right, so I'm just going to do several more, and then we're going to do some solving and things, and then we'll practice graphing every time, so we should get good at it. Now, this one, the problem is this doesn't read very well because the M is on the right. So we're going to turn it around so that it reads correctly. This is something you should write in your notes. In order to turn this around, we have to change the direction of everything. So M will be on the left. The inequality also has to change directions, and then the -3/2 is now on the right instead of the left. Now, the thing to notice to realize why they're the same is you see that the pointed part here is towards the M, and over here also the pointed part towards the M. Okay, so this one we would read -3/2 is greater than or equal to M. And that's just a little weirder to understand because M is the thing that's varying. So it just makes more sense to do it this way, and this is the way you should always rewrite it. So we do want the variable to end up on the left, no matter where it ended up. But just make sure, so this is something to write in your notes, when you switch this around, you switch everything switches. So the two side switch, but also that inequality has to turn around. So make sure you make a big note of that. So then to graph it, and we'll see when we look at this graph how that actually makes sense. So if I do the graph, so again, I just stick 0 there in the middle, and then I'm just going to stick a -3/2 on the graph. Okay, rather than putting all the numbers there and everything, that's just a lot of extra work. Doesn't really matter, just that negative is to the left of 0, so just make sure -3/2 is over there. So this says M, and by the way, over here I could have written an X right here because that one was X. So here, if we wanted to, we can write M, just to show that whatever's on this number line is what M is. So this one says less than or equal to. So that's how that one's read, less than or equal to. So equal to means square brackets, but this time we are less than or equal to, which means everything that gets shaded is going to be to the left. So less than -3/2 is left. Smaller Less is to the left, greater is to the right. So that's how that one would look shaded. Okay, now if we look at this one and we just try to see if this makes sense, well, it says that negative 3/2 is greater than or equal to all m's. Well, if you look at this graph, that makes sense. Negative 3/2 right here is greater than everything that we've shaded. So it still makes sense. Just typically turn it around. It's going to make it easier. Now, to draw the interval notation here, remember we always go left to right, smallest to largest. Well, smallest has got to be a parenthesis, and it's coming from minus infinity, because that's what this is. This arrow says we're going on forever in that direction. So all the way to minus infinity and up to, so we put comma, negative 3/2, and this had the equal to part on it, so we have to include it. So it's a bracket, not a parenthesis. Okay, so that's all it is. And the more you practice, the easier it will be to read that. You just have to do it enough for it to get easy. All right, so now this next one we're going to graph on a number line. So this one's a little different. This is in between. So I'm going to draw my number line again, and I'm going to put a T here because this is what T is. And I'm going to put the two numbers that are relevant, which is -5 and 0. I don't need to write the whole entire number line on there because, again, it doesn't matter. It's every number. The numbers we put on the number line are just to show perspective because, you know, if we're picking things, this is every single number is on this number line. We just have to put hash marks to sort of give us an idea of where physically those things are located. So for this one, this basically is red. You can read this, T is between -5 and 0, including 0, because we have the equal to part here. So we would say inclusive of 0 or including 0 because it is included there. And so when we do this, -5 does not, there's no equal to part here. So -5 is going to have parenthesis, and 0 is included. You have the equal part, so you're going to put a bracket, and then you're going to shade everything in between because T is literally between -5 and 0. That's what it says, and that's what we're graphing. Now to do the interval notation, again, super easy. You're going to have parenthesis on one side, bracket on the other, because that's what this has on our number line. -5 is the smallest number, comma, 0. So that means that every number between -5 and 0 is what makes this true. So for example, -1 would be between -5 and 0. -2.758 is between -5 and 0 because -2.758 would be somewhere in here. Okay, so that's these solutions for these type of equations have a whole bunch of solutions, a whole interval, so we have to write them a little different. Okay, so now let's talk about solving them. Because we're solving linear inequalities, and we're going to talk more about linear stuff later, but basically it's because your variable is raised to the first and there's only one variable. There's not two different variables or anything, but mainly because it's raised to the first, and this is a linear inequality. So you're basically going to solve this the same way that we would if that was an equal sign instead of the inequality. The only difference will come if we have to multiply or divide by negative. And during that step, we'll have to flip the inequality. And that's it. Otherwise, everything's the same. So right here, we're going to solve it just like that was an equal sign. So we're going to subtract 7 from each side. So on the left, you're going to have x. And now instead of equal, you'll have less than or equal to. You leave that sign. Stay keeping it lined up, though, just like you do with equal signs. And then you have 12 minus 7, which is 5. And then we're supposed to graph on a number line. Well, I'm not going to graph every one of these on a number line, but I will graph a few of them just so we get good at it. But again, you're drawing a very fast number line. You can put 0 on it, and then put 5. And the only reason I put 0 is it just sort of divides the positive and negative. That's really it. It doesn't really matter. You could literally just put 5 on here and it'd be fine. Then this number line represents x. So whatever's shaded on here is all the values of x that will make this statement true. So x is less than or equal to 5. So equal to means bracket, and less than means it's going to point here to the left, and less than is this direction. So we shade to the left and we fill in our arrow to make it obvious that everything is shaded that direction. And then for our interval notation, again, it's coming up from minus infinity. The infinities always have parenthesis, comma, 5, and you can see from the graph 5 has a bracket. Now, it does matter. It always has to be smallest on the left, largest on the right. Okay, so make sure that you pay attention to that because you can't, it doesn't make any sense to do it any other way. So that's why equating it to the number line makes sense. Everything that's shaded here is from this side. All right, so let's solve this next one. So this is actually the reason that we do the whole try to get the move the smaller variable first to end up with positive in front of the variable, okay? And that's because on inequalities, if you multiply or divide by negative, either way, if you multiply or divide by negative, okay, by a negative number, you flip the inequality. Okay, it stays equal or not equal, whichever it is, but the inequality part has to change. So if we can avoid having to do that, that would be great, because we would just not have to deal with that. And that's part of the reason that I teach it that way. So when we look at our two variable terms, we have negative 4z and we have negative 5z. Now let's think carefully about this. Negative, if you're on the number line, negative 5 would be smaller. Owing somebody $5 is more, or it's smaller than owing $4. So negative 5 is smaller, okay? So we're going to add 5 to both sides by doing that. So I'm going to actually just erase real quick what I put there. So it's out of the way. And so we're going to actually decide to add 5z to both sides. And you can also easily see when you do this enough times, you can see how that will give you a positive here, right? So positive 5 and a negative 4 will give me a 1z, which again, you can write 1 or not. I still have minus 2 over there. I have a greater than. Again, keep it lined up just like you do with your equal signs. Negative 5z plus 5z goes away, and then I just have a 1. So I do the same thing. I want z by itself. So I'm going to add 2 to both sides. So I'm going to get z is greater than 3, and then I'm finished. And then we're going to do a quick number line. So again, just draw a fast number line. This time I'm just going to put the 3 on there. I'm not even going to put the 0 because it really doesn't matter. We're just trying to represent what we have. This number line represents all things z. So we're going to graph z is greater than 3. So 3 is not included, and it's going to go to the right. So I use a parenthesis, not a square bracket, because there's no equal sign. And then greater than means to the right. So I'm going to shade to the right, and that's the answer for the number line. I'm also going to do interval notation. Again, you can pretty much just copy. That's a parenthesis. This is a parenthesis. We put a 3, comma, and then the arrow means I'm going on to infinity. And then infinities always have parentheses. You can put a plus infinity if you want, but it's not necessary. You do have to put minus for minus infinity, but no plus, just like with numbers, means it's positive. Okay, So on this next one, we're going to do the same thing. We want it to end up positive, so we're going to add 3x instead of the other way, because this is what's going to help us end up with positive in front of our x. So we're going to have 18 plus x less than or equal to, because negative 2x plus 3x is 1x. Negative 3x plus 3x is 0, so I just have 24 over here. And then you're going to keep doing your normal steps. You're going to subtract 18 from both sides. So that's going to give you x is less than or equal to 6. Then you're going to graph using a number line. And this time, let's just put 6 on there. Don't even worry about 0. And this number line represents x. So I'm just going to put a little x out there. It says x is less than or equal to, so that means square brace, less than. So that means I have to shade to the left, because left is less. Easy to remember, left is less. So we shade everything to the left, and I have the square bracket there because it's included. And then to do my interval notation is very easy, because this arrow represents an infinity. Since it's on the left, it's minus infinity, because those are negative numbers, comma 6, and then put square bracket because it's included. All right, let's do some more. So let's solve this inequality. Well, just like we did on the other ones, we're going to solve this just like this had an equal sign there, because it's linear. It's x to the first, so we just act like that was an equal sign. So the first thing we should do here is clear our fractions. So we want to find our least common denominator, which is easy here because there's only one denominator. It's 3. And so you're going to multiply both sides by 3, just like we did before. And again, as long as you don't multiply or divide by negative, everything, just leave the sign the same. Everything's just like we were doing. And then you're going to divide out. So I divide by 1, or divide by 3 leaves me a 1, divide by 3, divide by 3, divide by 3. And then I'm going to write down what's left. So I'm going to have 2x on the left, less than or equal to, because that's going to stay the same. And on the right, I just have negative 10. So again, we made the problem super easy. So I'll go ahead and use colored this time, but I think we're getting pretty good at our solving. So we would divide by 2, and then we would get x is less than or equal to negative 5. So just make sure you keep your inequality sign in there. And I'm just going to put negative 5 on there and not anything else. It says this is the number line for x. It says x is less than or equal to. Less than is left. Less is left. So I'm going to put square bracket here because it's equal. So equal means I'm including negative 5. Less is left. So I shade left. Less is left. And then for interval notation, when you have an arrow, it's an infinity. Since it's on the left, it's a minus infinity, comma, negative 5, and square bracket, just like we used there. All right, so now let's go to this one on the right. So same here. This has the same least common denominator, so we're going to go ahead and multiply both sides by my least common denominator, which is 3, because we definitely want to get rid of that denominator. Then you're going to go through and you're going to divide out, divide by 3, divide by 3, just like we did on the, if it had an equal sign. Then you're going to write down what's left. So on the left, there was no denominator, so you just do 3 times negative 8, which is negative 24. You keep the less than sign, and then you're left with a minus x. So here's where we don't have a choice. To get rid of that minus x, we need to divide both sides by negative 1, because we have to get rid of that negative 1 that's in front. Well, as soon as I do that, it means that this inequality has to flip. Very important. So this would be a good place in your notes. You can even pause the video and I would write a note to myself, because we had to do multiply, or we had to divide by -1, we had to flip the inequality around. So instead of a less than, it's a greater than. Now we simply write down what's left. -24 over -1 is 24. And then negative x over -1, negative over negative makes positive, and we get x. Now we have that problem where the x is on the right and it doesn't read very well. So now we're going to flip this whole thing around, which means we have to flip everything. So we do x, we flip the inequality to less than, and then we put 24. And if you read this, 24 is greater than x. That means 24 is bigger than all the x's. That's the same thing as saying x is less than 24. So here's a perfect example of why we don't want to put all those stinking numbers on the number line. We'd be here all day trying to number to 24. Just stick a 24 on there. X is less than. Less is left. It's not included, so put parenthesis and then shade to the left. And then to do our interval notation, again, we're including the arrow. Arrows are infinities. It's the left arrow, so that's minus. So it's -infinity to 24 and non-included. All right. So let's do a couple of inequalities that have a few extra steps in it, but it's no different than the way we did this before. So it's just like this had an equal sign in it. I do the same type of solving. I see that I need to distribute on both sides. And so I'm just going to distribute, and then I'm going to solve just like normal. So I have 9x minus 48 is less than 12x minus 24, because I'm distributing and multiplying. Okay, so you distribute that. Now, again, just like always, we act like this is a brand new problem. So we want to leave in front of the x positive so that we don't have to forget when we multiply or divide by negative. So we're going to subtract 9x. That leaves me a positive x. As you can see, you'll have 12 minus 9x. So that gives me -48 is less than 3x minus 24. And then we're going to solve from there. So we're going to add 24 because that side already has both x and variable. Left only has one. So on the left, we're going to end up with -24 is less than 3x. Let me scoot this other problem over here. And then we'll finish this one. So we're going to divide, just like always, divide by 3 because I'm trying to leave a 1 in front of the x. And so I have -8 is less than x. Now again, we don't want that on the left, or that we don't want the x on the right like that. So just turn the entire thing around, including the inequality has to flip. In other words, it's pointing towards the -8, so it still has to be pointing towards the -8. Okay, so when I flip it around. Now to number line, we just draw the number line. This is the number line for x. We just put a -8 there. This time x is greater than, not including, so greater than's to the right, but we don't include, so we do a parenthesis, and then we shade to the right because it's greater, and greater is to the right, less is left. And then we just put the parenthesis because that has a parenthesis, -8, comma, infinity, close off, and you're done. Now let's go ahead and do this last one. So we have to do a couple of things here. I see parentheses and I want to get rid of those parentheses, or not parentheses, I see fractions. So I want to get rid of these fractions. Don't distribute first because that's just going to give you a lot of work. So you need to find your least common denominator. Well, when one of the numbers divides into the other one, then that bigger number is always going to be your LCD. You can practice your process, but that's what you're going to get. So we're going to multiply the left by 21 and the right by 21. Now don't confuse yourself and think you have to multiply inside here, because this is one big term because it has multiplication here. Then I'm going to reduce. So I'm going to divide by 21, divide by 21. On the right, I'm going to do the same thing. The 7 just happens to be over here, but this is multiplication. This is multiplication. I just divide by 7, divide by 7. Then I'm going to do the same thing. I'm just going to write down what's left. So basically this is 8 parentheses x plus 2 is greater than, here I'm going to have this 3 times 1. Make sure you realize that. 3 is times 1, and that's what's outside the parentheses, and then you have x plus 3. Now we're going to do just very much like what we just did over there. We're going to distribute on the left. So we're going to get 8x plus 16 greater than, keep that, distribute here, 3x plus 9. And since this is a video, you can always slow it down. Just pause it if you need to catch up or think for a minute. Just hit pause. Then you can start it again. So at this point, I want to subtract 3x because we're always going to move the smallest variable term. In this class, again, not the only step you can do. That's just what we're going to always do. So we get 5x plus 16 is greater than 9. And then we're going to subtract 16. Hopefully all of this solving is getting really easy because we've done it over and over and over. So we have 5x is greater than, if you do 16 minus 9, you're going to get 7, and then it's negative. And then you're going to divide here by 5, divide by 5. And so your answer, just leave that fraction. It's perfectly fine. You're going to have x is greater than negative 7/5. And this is where, again, on the number line, that's why we don't draw all that stuff in. Don't worry about it. Just have a number line. Put an x here so we know this number line is for x. Stick negative 7/5 on the number line. This is x is greater than. Greater is to the right. We're not including, there's no equal sign there, so we've got a parenthesis, and then greater is to the right. So we shade to the right, and then to do our interval notation, you're going to put parenthesis because that has parenthesis, negative 7/5, comma, infinity. All right, one last thing. We're going to set up a couple of statements. So we have worded problems here, and we're just going to set them up and then solve them. Now, the only difference that we have is this might say less than instead of is equal to or is. But we're going to basically just left to right here. 8 more than twice a number. So 8 more than twice a number, we use x for the number, is less than negative 12. So super simple to set up. We just basically go left to right and write that one down for this one. And then we want to find all numbers that make this statement true. So that's the reason there's a lot of numbers that will make this true. For example, if I had negative 1,000, this is going to be true because you'll have negative 2,000 plus 8. That's definitely less than negative 12. So there's lots of answers here, so we have to have an interval for this. So you just solve what you ended up with. So we're going to subtract 8 because that side is mixed. And we're going to get 2x is less than negative 20. And then you're going to divide by 2. And you're going to get an answer of x is less than negative 10. And we could just stop there and give this answer because that's what it asked for. Find all numbers that make this true. X represented the number. So any number that's less than negative 10, if you were to plug it in here, it would be true. Now remember, less than, just to look at the number line, that'll help you. If we're at negative 10, less is to the left. So any number that would be to the left of negative 10. So like negative 20 or negative 11 or negative 10.5 or anything that's to the left over here would make this statement true. All right, one last problem and then that's it for this lesson. So basically this says one side of a triangle is 6 times as long as another side and the third side is 8 inches long. If the perimeter can be no more than, that's what's different here. So this is an inequality. No more than 106 inches, find the maximum length of the other two sides. So to find the perimeter of a triangle, you're going to add up the 3 sides. So let's figure out what they are. One side is 6 times as long as another side. So we're going to have side number 1, side number 2, and side number 3. Okay? And we're going to write an expression for what we get. So one side is 6 times as long as another side. So we can say, we can call side 1 can be X. And then one of the other sides is 6 times as long as that. So 6 times X. And it doesn't matter which side I call what. There's 3 sides. So we'll just call it, we don't know any of them, or we don't know these two, so we'll call one of them X. And then it says one side is, so this side, number 2, is 6 times as long as another side. And the third side is 8. So it is known. And then it says about the perimeter. So again, read the problem several times, see if this makes sense to you, figure out why that makes sense. But then they say perimeter, and we remember perimeter is just add up all the sides. Well, here's the 3 sides right here. So we simply put a plus sign between all of those 3 sides, and that's the perimeter. Well, what they tell us is it can be no more than, so that means it's less than 106, no more than. So it can't be more than 106. Now, let's decide if it can be equal to, no more than 106. So it can be 106, it just can't be more. So we're going to put an equal there. And then it says find the maximum lengths of the other 2 sides. So basically that just means solve this because side number 1 has to do with X and side number 2 is 6X. So we're just going to go through the normal process. We need to add these like terms together. 1X plus 6X is 7X plus 8 less than or equal to 106. Again, remember this is a video. You can stop it, pause it, rewind it anytime you want. All right. Now we keep solving. So we're going to subtract 8 from both sides, and we're going to get 7x is less than or equal to 106 minus 8, which is going to be 98. And then we're going to divide by 7, so we get x is less than or equal to, and if you divide 7 into 98, you're going to get 14. So what that tells me is side number 1 is, it says find the maximum length of the other 2 sides. So if side number 1 is x, x at most is 14. Because this says x is less than or equal to 14. So if I have 14 on here, I'm including it, and x is anything less than that. So to the left. So the biggest, the maximum is 14. So the maximum of side 1 is 14, and they told us inches, so we're going to say inches. And then the max of side 2 is going to be 6 times x. So it's going to be 14 times 6 would be the biggest that it can be. So that's going to be 84. So that's the maximum. Now, if we add it up, we can see how that makes sense because it can be no more than 106. So if we take the biggest of side 1 plus the biggest of side 2 plus side 3, which is already fixed, if we add all this up, we do in fact get 106, which makes sense because that's the biggest. And this is the max of the sides. Okay, so the biggest the sides can be gives me the 106. So that means the other two sides can be smaller. They just have to be in this perspective. So let's say side 1 was 10 because that's less than 14, then side 2 would be 60. If side 1 was 5, because that's less than 14, then side 2 would be 30, and so on. Okay, so that's it for this. Certainly rewind the video, watch it again if you need to, but that's our lesson 9-6.